Okay, ladies and gentlemen, welcome in. Exciting day today. You're going to hear all about your projects for the upcoming school year. So just a reminder, this is a meeting for us where we're going to showcase and display all the projects that we have that you could possibly work on for next year. Very exciting. So let's just get right into it. I got a lot of projects to talk about. Um, Before we get into the projects, let's talk about what's going to happen after the meeting today and how you're going to provide your project preferences. So after this talk, I'm going to email you all a link with a form that you can fill out to provide your preferences. I'm going to put the link in there after this is over and send it out. All right. So please fill this out by next Friday. So I'm giving you over a week to do this. If you don't fill out the survey, you might not get the project you want to work on. You might not be able to work with the people you want to work with. So please fill it out, in short order. I'm going to close that survey the following Saturday, the 20th. So yeah, do that. Right. So this only gives like a brief overview of each project. Most projects have a longer description, and I put the full proposals, the longer descriptions in the box folder that you see there. Okay, so when I send this out, you can click on this link and you can look at all the project descriptions in much more detail if you want. All right. Now, the project preference form, you're going to have a couple of different things that you're going to fill out when you fill out the form. I'm asking you to rate every single project on a scale of 1 to 5. You are also allowed 1/6, which is your most preferred. All right. Don't just give me all ones. All right. Help me help you. I can't guarantee that everybody's going to get their 6. Like in the past, I've done pretty well. I think like the average happiness last year was about like 5.6, which is actually insane. 5.7, something like that. So that's that. You'll also be asked who you might want to work with and whether or not the project is more important to you or the people are more important to you, or if you're neutral on that idea. So it's going to look a little bit like what you see on the slide. Please fill it out. You can fill it out in portions as you go. So it doesn't all have to be done in one go. You can sort of fill it out a little bit, then come back later and whatever. But please submit it by next Friday. All right, let's get into it. So first things first is industry projects. So these projects have some industry affiliation and will likely be co-advised from somebody in industry. So like Milwaukee Tool, we have an Enerpac project. We have a lot of industry projects coming up. You're probably going to have to build a prototype and present it to your industry sponsor at the end. Like maybe you'll have to go to Tool and present your project to them. Okay. Industry sponsors provide money for your prototype, so you will have lots of money. That's a good thing. All right. First things first. Let's talk about Tour of America's Dairyland. So the Tour of America's Dairyland is it's a Wisconsin-based company. It sponsors cycling events in summer months around Wisconsin. I think their first ones are coming up like at the end of April, actually. So they use these like metal barriers to protect pedestrians from the cyclists. And what they want the design of something that goes over the top of this barrier to stop some of the cyclists, if they crash into it, from their limbs getting caught into this like metal barrier. So this one's a little bit wild, but they want something to give a little bit more cushioning and provide some safety for the riders a bit. All right, so there's some human factors in here, experimentation, because you're going to have to build something, put it on, and then maybe do some impact testing or something like that. And if you're into like cycling or sports or things like that, this one might be for you. All right. There's a company in sort of downtown area of Milwaukee. They're actually near the Third Ward, called Ingle Forge, which is a tool and die company. They use induction-based heaters to heat up metal, and then you have to heat up the metal to do forging, right? To shape the metal into the shape that you want. And the way that they do this is they shape the metal into the shape that they want, and then they put them in these storage bins hot. And these guys that are working at this forge are like, man, this is just a lot of wasted energy. Is there some way that we can extract like the energy of these things cooling down into some useful energy that we can use later? So the idea here is, can we take the heat energy coming from these pieces and use that to turn into electrical energy somehow, or store in a battery that we can use later, or whatever. All right. So your task is going to be to design some fixture that these things can go in and cool. That can actually reclaim some of the energy lost from these things cooling down. So if you're interested in energy harvesting, heat transfer, thermodynamics, this one might be up your alley. Hellwig. Hellwig's a company on the north side of Milwaukee. I think they're almost into like Grafton area. That manufactures components for motors and linear actuators. They want to design and build a test stand capable of testing electrical components that gets used over and over and over. And specifically, they're looking at electrical contacts subject to fatigue wear. So a lot of times, if you have like linear sliding components, they'll reach like a limit switch on one side and a limit switch on the other side. And that switch gets constantly activated and deactivated and etc. And they want some sort of test stand that will repeat that action over and over and over and over for hundreds of thousands or maybe even millions of cycles to see how long it takes for that electrical component to wear out and to fail. So if you have interest in mechatronics, fatigue failure, experimentation, dynamics controls, design of experiments, this one I think could be really cool. So this is kind of what I'm talking about here. You have this black thing that slides back and forth on these like copper looking rails. They might touch some switch on this side, touch some switch on this side as part of normal operation. And so you just get a lot of wear on these electrical switches, and they want a way to test those and see like how reliable they are after, let's say, 100,000 cycles, for instance. All right. Delta Hawk. Delta Hawk is a jet engine design company in Racine, which is south of here. It's my hometown. I grew up in Racine. Actually, their building is like a half a mile away from the high school I went to. It's kind of funny. But they design and install aircraft engines on small aircraft. They're requesting a team of seniors to investigate creating some of the engine components, their engine components, out of polymer or fiber reinforced polymer composites. So carbon fiber, right? Carbon fiber epoxy, basically. This is something I'm going to advise for sure. Composites are at my alley. Many of you know that I teach the composites elective. And if you're going to be a part of this project, you have to enroll in my composites class. So that's MEC 4676. So this might be of interest to you if you're interested in engines, heat transfer, composite materials. Obviously, you can't put polymers in every location inside of an IC engine. They just won't hold up to the temperatures. But maybe intake manifold or some of the piston covers or something like that. We'll have to look at the engine in a bit of detail and decide how we want to do this, but you'll probably be making a lot of metal molds, manufacturing composite materials, and deciding whether or not it's going to hold up to the engine temperatures. All right, this is a picture of one of their engines, by the way, that they mount on aircraft. Enerpac. All right, Enerpac's a manufacturer of industrial tools, and they're headquartered in Menomonee Falls, which is west of here, not too far, maybe half hour on 94. They have 3 projects that they propose to us, and I'll go through the 3 of them here. The first is a hydraulic lifting cylinder and a way to detect how much the cylinder has shot up. So here's kind of the cylinder on the right-hand side here that would be lifting some object, right? So hydraulic cylinders are often used to help you lift things that are heavy, too heavy for your personal, weight, your feeble bodies to lift on their own. And what you see here in line, this is called a string potentiometer. So there is this little hook here that you see on this device that would have a string attached to it. And then this would connect up to whatever device that you're lifting. And as you lift that thing up, this potentiometer changes its resistance, and you can detect how high up that object has moved from, the cylinder. The problem is, like, a lot of these are used in industrial locations. So think grease and dirt and all sorts of nastiness. And so the spring that attaches from this hook up to the device at the top can sometimes get contaminated. And that's not so great. So they want to design a different method for measuring how high up these objects have been displaced from the starting location or from using their hydraulic lift cylinders. And so not exactly sure how that's going to be done, but there's a lot of ideas that you can maybe go with. So it's good for people with interested in fluid power because these are hydraulic cylinders. So you have some fluid there that you might be able to use to sort of maybe do some detection there. Sensors and actuators and statics. This is a lot to do with statics. So if that was a class that you enjoyed, there's going to be a lot of static equilibrium you'll have to consider in this particular project. Moving on. The second project that Enerpac has sort of proposed to us is the redesign of a gearbox for a battery-powered torque wrench. So here you see some torque wrenches on the right-hand side. Sometimes they're battery powered, sometimes they're not. Enerpac has just started manufacturing ones that are powered by batteries. So typically torque wrenches require a very high amount of torque, and you typically want to have a lot of power, and so batteries are not great. But they've gotten into the battery space for making torque wrenches with battery power. And so they have certain gearboxes that they use to get certain output torque ratios, but they would like a new design or sort of an overhaul of their design to look at getting higher torque outputs from their sort of handheld batteries there. So if you like gearbox design, so design of machine components, if you're in that class, you enjoy that class, FEA is going to be a big part of this because you have high torques. Rotational powder, rotational power, and machine components. This could be something that maybe you're interested in. Last for Enerpac is more of a chemistry-ish kind of project, not fully, but they designed pumps that have oil basins in them in the bottom. And one problem is if you have this thing running for hundreds of thousands of cycles, this pump for hundreds of thousands of hours, let's say, over the life of the pump, the internal oil flow pathways can become restricted or contaminated with debris or whatever. The oil will sludge up over time, and the viscosity will go up and things like that, right? So Enerpac wants an MSOE group to investigate like what are the problems associated with some of the oil reservoirs that we have, and can we design a better contamination mitigation system? So better filters, whatever that entails, or a better maintenance plan for how often you have to replace the oil and things like that. I think they have a couple of pumps in mind specifically that they want to look at, but this has maybe a bit of a chemistry spin too, because maybe you just suggest using a different oil. So maybe if it's something you're interested in, rheology, if anybody took the tribology class or is interested in the tribology class in the fluid power realm, maybe this one is something you could be interested in as well. All right, on to Milwaukee Tool, the competitor of Enerpac, kind of. So Milwaukee Tool, I think everybody knows Milwaukee Tool. It's a company that develops and sells a wide range of like hand tools, power tools, etc. They proposed two projects for us this year. The first is the water cooling of sort of an electrical board, right? A PC board assembly. So they use these cutting tools to cut through concrete. And you can imagine that the tool here, as it's cutting through the concrete, gets very hot. So if you're looking at this picture, you sort of see this hose connected to the bottom of the tool. That hose is actually used to cool the inner workings of the tool itself. One other issue, though, that they have is that the actual interior housing here, which holds the PCBA, can get very hot as well. And sometimes the solder joints can come loose. That's not good. So what they want to do is they want to use the water to not only cool like the working mechanical components, but also use the water cooling to water cool the PCBA. So some of the electronic components. So how feasible is that? What would that look like? Can you design some cooling system? I think like if you've ever seen like a water cooled computer tower, that's kind of what I think of in my head. Like how do you cool electronics with water cooling? I would inspire my design from something like that. But okay, if you're interested in fluid mechanics, heat transfer, CFD, power tools, this one could be for you. The other project that Milwaukee Tool has proposed is incorporating ventilation into some of their gearboxes. So many products that Milwaukee Tool utilizes as gearboxes, and they want to keep lubrication contained inside of the gearbox. So a gearbox has got obviously moving gears inside of it, and usually it's surrounded by some sort of lubrication on the inside, oil, right? And the problem is that oil can get very, very hot. They say sometimes upwards of 180, 200 C, which is getting pretty hot. And when you're getting that hot, some of the rubber seals or O-rings or things like that can degrade and possibly start to leak. So what they want to do is they want to design some sort of ventilation cooling system that does not leak oil that they can use in their gearbox housing. And there's some kind of like ventilation devices that already sort of exist. Here I just snapped this one from like a YouTube video. It's called a pressure relief breather, but it's something that can go onto like a gearbox housing to relieve pressure without the possibility of oil leaking out from that ventilation chamber. So there's some kind of tricky fluid mechanics that you could leverage there to maybe work on that. So fluid mechanics, if you're interested in that, heat transfer, valve design, because you'll probably have to look at a valve here. If this interests you, might go after this project. Okay, onwards. EPS pumps. EPS is a pump inspection and repair services company. It's based in Mugwanago, which again is close here to Milwaukee. And they want kind of like a demonstration unit for when they bring to trade shows and like student recruitment, student fair events. So it's kind of hard to understand exactly what a pump services company might do if you don't really know much about pumps. And so if you're going to a trade show, it would be nice if you could have like a tabletop centrifugal pump that you could just like assemble and disassemble and show somebody like the inner workings of a pump and how it works and things like that. So they actually want to design a little showcase, like maybe 10th scale centrifugal pump or something like that. I think of this almost as like curating a museum exhibit for like a 10-year-old, right? Of like, this is a pump and this is how it works, you know? So if you're interested in fluid mechanics, fluid power pumps, and specifically like education, right? Because you want to be able to like disassemble this, maybe you're labeling some of the parts to showcase like what each thing does. Um, I kind of like that project. Maybe you 3D print everything. I don't know. Could be kind of fun. The STEM Center. The STEM Center is always looking for educational demos. So the STEM Center at MSOE does a lot of stuff with K through 12. One of the things that they do is they do 1.5-hour hands-on lectures, so 90-minute hands-on lectures for K through 12 classrooms throughout the academic year. They're always looking for fun projects for those students to do, and they want to do something related to engineering. They always do, and they're specifically asking for fluid power through this proposal. So looking to add an engineering activity that teaches students about fluid power through a hands-on standalone activity. Immediately, what came to my mind is the popsicle scissor lift. So this is my idea. I mean, you don't have to do this. You could do something else, but anyone ever see these demonstrations where you're kind of like pushing fluid through one side of the syringe and it goes to the other and that somehow raises the scissor lift? I think it's kind of a cool little thing to show young students. But fluid mechanics, fluid power, and again, this like education component about how are you going to teach somebody how this works? They're maybe going to build it over a 60-minute period and then learn about it for 30 minutes. You sort of have to design the lesson too, not just the device. So kind of cool there. There's a private client that wants to maybe develop a prototype invention that he has. So this is somebody that has money and looking to use the MSOE seniors maybe to develop a prototype idea that he has. So his idea is that sump pumps are often used in the basements of buildings. You probably have one in your basement, maybe at home. And basically, you collect water into this basin inside of your basement, and the sump pump pushes the water out. And one of the issues is sump pumps are often powered by electricity. And if you have heavy storms where water might be coming into your basement, if those storms knock out the power, you're kind of out of luck because you have no way to push the water that's coming into your basement out of your house, right? So his idea is to develop a sump pump that doesn't work by electrical power, but works by some other type of power. Like specifically hydraulic power, I think would be quite good, right? So you can imagine if you got a lot of liquid, puddles or whatever, maybe forming at the surface here, ground level, maybe you have some way to divert like water from ground level using like gravity as a lever to give you some pump head and possibly pump water out using some sort of mechanism. All right. So if you have, again, interest in fluid power, fluid mechanics, I realize we're doing a lot of fluid power stuff here at the moment, but this one might be for you. As a heads up, if you are going to do this project, you have to sign an NDA and you have to give up your rights to IP if you're going to work on this project. So any IP that's developed by this project is going to be owned by the private client, not by you. So just keep that in mind if this is interesting to you. Next, this one's kind of a animal related. So NutrusRx is a company based in Wauwatosa that formulates pet foods and pet products, basically. And they want to design a device which automatically dispenses items from a large container into a smaller container at various ratios. So what I'm imagining is you're going to the vet office and you have, you know, item A, item B, item C, and item D that you could possibly put into a food to give your dog. And you need a certain combination or ratio of those four things. You press a button and those ingredients combine into one object that then the vet takes and gives to you. Okay. That's the idea behind what NutrusRx wants to do. They basically want to make some sort of storage device that stores a lot of items that get combined and given to a client at the end after some sort of mixing happens, almost like a pharmacy in a way, right? So this one I think would be kind of fun, especially if you're a pet lover. I have a dog. I love pets. So controls and microcontrollers, instrumentation, mechanisms, food safety is going to be involved a little bit here. And then if you like pets, you know, maybe you can test your device on some dogs or something. All right, moving on. Right Height. Right Height manufactures, you know, loading dock equipment, industrial doors, safety barriers, garage doors, things like that. Right Height's looking for a bit of an electrical slash mechanical product. And specifically what they're looking for is something that analyzes printed circuit board assemblies, right? PCBAs. So this is a picture of somebody analyzing a PCBA. So at the end of a line, at the end of production, you'll see a PCBA here inside of this test chamber. And you see all these probes that are coming down from this like assembly. Basically, you close this hood, all these probes make contact with important pieces on this PCBA, and will tell you Are they connected? Are they not connected? Will it work? Will it not work? Okay. So Right Height has a PCBA that they want to make a testing chamber like this for. So bring the lid down, make electrical contacts. Does it work? Does it not work? Showcase, yes, it's good. It passes. No, it doesn't pass. This particular circuit's closed. So you need to work on that. And that's what they want to do. This is actually a multidisciplinary project in conjunction with electrical engineering. So there'll be some EEs on your team and some MEs on the team. So if this interests you, this one could be kind of cool. I think there's a lot of mechanical design that goes into how this thing operates and how this thing works, and you'll interface with electrical engineers. It's nice, like multidisciplinary type project. Keeping going, let's get into the medical side of things. So MCW is the Medical College of Wisconsin, and they're sponsoring the design and build of an additively manufactured cranial helmet for those with, don't make me say this word, plagiocephaly. Yeah, plagiocephaly. Yeah, okay, I don't want to say it, but yeah. So there's a cranial helmet here, and they want to 3D print a version of this that can be custom fit to particular patients. Everybody's head's a bit different shaped, so if you can make a custom version by 3D printing, that would be ideal. Their focus is on lightweighting and comfort, and this might be some inspiration, is using lattice structures in the 3D print. So here's some sort of lattice structure. You can make a lattice structure that's tailored to a certain stiffness and strength, and it's going to be lightweight. So maybe 3D printing of a lattice structure to use in sort of some helmet like this. All right. If you got interested in medical devices, FEA, ergonomic factors, this project could be for you. Moving on, Hanger Orthotics, Hanger Clinic. Hanger Clinic is a prosthetics and orthotics clinic which exists in Milwaukee, and they're looking for the design and prototype of a device which can sort of connect to a foot and help correct the gait of somebody that normally walks like on their toes, right? So this device is meant to sort of like push the ankle down and enforce that the heel makes contact before it allows you to sort of roll up and have like a normal gait pattern, right? Instead of just walking on your toes. So this has a bit of mechatronics component, has a bit of human factors, medical devices kind of components to it. You have to consider materials here because you want them to be lightweight and comfortable for the patient. So that is one possible project. Here's an ankle foot orthotic, by the way. What you're looking at is adapting a typical ankle foot orthotic to automatically control the gait, right? Okay, next. Those are all the industry proposed projects. Next are faculty proposed. So Dr. Mahintala has proposed to participate in the ASME design competition. He's done this every year for several years now. And each year the design competition revolves around usually making some kind of robot, right? MSOE has traditionally done like pretty well in these ASME like design competitions. So previous years have been, for example, football playing robots. And so if you want to take a look at a football playing robot, you can look at this video after I send this link out. But okay, football playing robots. So if you're interested in robotics, mechatronics, mechanics, controls, this one might be for you. Don't know exactly what the prompt is going to be until like mid to late summer. So you're taking a bit of a gamble doing this one, but it's going to be something robotics related. Okay, Baja team. The SAE Baja team at MSOE is always looking for updates or redesigns to some of their subsystems. It's a bit unclear exactly which subsystems they want to go after this year, but if you're on the Baja team and you want to work on some of the subsystems as part of senior design, this one might be for you. So some of the vehicle subsystems of particular interest for next year that you might work on is front and rear suspension. So that's these little springs here, anything that basically connects to the wheel, drivetrain, and general weight optimization for the vehicle. So if you're interested in vehicle dynamics, competition teams, mechanics materials, FEA, probably going to be involved in all these. Consider this one. Fluid Power Vehicle Club. So each year there's a fluid power vehicle competition where the task of the students is to design and build a vehicle that runs on fluid power. So this is the design from several years ago. They've done this a lot now, but this one actually, I think, ended up winning the competition totally at the end, which is kind of cool. But you see kind of this bicycle here, but there's this manifold that has some fluid in this reservoir that ends up pedaling this bike and powering this bike, right? So they have a design competition every year to build a vehicle that uses hydraulic or pneumatic power. And so if you've got interest in fluid power, instrumentation, automation, vehicles, things like that, this one could be for you. Dr. Williams, he's got problems with his gutters, apparently. He's proposed an automatic gutter cleaning robot. I think this one kind of speaks for itself, but you know, gutters get clogged with leaves every fall, especially if you have a lot of trees in your yard. And Dr. Williams wants to design a robot that can automatically clean these out. Think of like a Roomba, basically, but for your gutters, you know? So something that runs by battery power, so without connecting to a power source, is what he's desiring. So controls dynamics, mechanisms, robotics. How do you get in, scoop stuff up, throw it over the edge, or collect it in some bag? Who knows? Maybe you got a bag on the back end that's collecting all the stuff. This one could kind of be fun to play around with. Maglev. This one's kind of sexy. Dr. Wang, he's kind of new to the ME faculty, but he wants to incorporate maglev as a concept in the controls lab. So he wants to develop or build some device that can showcase maglev and that might be used for the auto controls class. I think it's 4310 is the number. I'm not quite sure. You guys are probably going to end up taking it in the fall. But yeah, if you really liked your physics 2 class about electricity and magnetism, to me, those ideas are not so comfortable, but maybe you like that sort of stuff. And you're interested in dynamics control, if you're interested in education, again, you're possibly developing this for the auto controls class. And there's going to be some like simulation probably associated with this. So MATLAB Simulink, you got to probably enjoy working in those. Also, there's a requirement that you need to be enrolled in the auto controls class this upcoming fall. So basically have to pass dynamic systems and have to have passed instrumentation already and must be enrolled in auto controls to take this class. But you know, most trains, high-speed trains, utilize this general concept of maglev. So I think it'd be cool to kind of see some live demo of this working and be built into that auto controls class, right? I think that'd be kind of cool. Mechanisms design challenge. Ooh, man. Slayback kind of threw this one down and he said, all right, I want a bunch of teams that are going to design a mechatronic device of my description and sort of like see what we can do. The idea here is that there's going to be some design challenge. And the design challenge, he's done this in the past, but at a different university, where he's had students like making an automatic dice rolling machine. So this is an automatic dice rolling device. An automatic pancake maker. You see here like an automatic pancake making device. This thing is like flipping pancakes right now. Automatic Skittle sorter. So here you can't really see them all that well, but there's some Skittles here. Did my headphones just go out? I think my headphones might have just went out. Can you guys hear me still?
Yes.
Yes.
Yeah.
Yes.
Okay. My headphones are making some weird noises. Sorry about that. Right. So there's some Skittles here, and there's something that can pick them up and collect them, etc. Okay. So if you're interested in mechanisms, controls, robotics, Dr. Slayback is looking to field like many teams for this project. So maybe there's like 4 or 5 teams that are going to do this. Who knows? I don't know. And so aside from sort of like this mechanism design challenge, he's also proposed sort of a separate but similar idea is a mechanism design competition team. So this is a project that's intended for students interested in MSOE's mechanism design club competition team. So this is more of a competition team. The other one that I listed previously is more like in-house, just kind of for fun, making mechanisms and designing them. This one is meant to be addressing the design challenge of this ASME IDETC student mechanism and robotic design competition. That happens every August. And so you'll design something over the course of the school year and then go compete in this competition in August. Don't really know the exact prompt for this mechanism design challenge yet. That's going to come out later. So again, interest in robotics, controls, mechanisms, and if you want to be on a competition team, this one is for you. If you don't want to be on a competition team, do this design challenge. You don't have to go to competition. You can just make some fun mechanisms, right? So that's that. Dr. Vyas wants to harvest wave energy. I think this one's kind of cool, right? So if you're interested in fluid mechanics, energy harvesting, he wants to basically make something that converts water waves into electrical energy without the use of an air turbine. So that is very specific. I think there's some wave energy capturing devices that use water turbines and wave turbines. So he wants something that works without that particular component. All right, to qualify for this, you have to have completed the manufacturing classes and also be signed up for auto controls in the fall. Okay. Next, design, build, fly. So Dr. Fleming, each year, he has a couple of groups compete in the design, build, fly competition. And in this competition, sponsored by AAA, you design and build a unmanned aerial vehicle, UAV, to achieve some task. That task is yet to be determined. They'll have the competition prompts usually out midsummer, where in the past, some of the competitions have been like transport medical equipment in a UAV from one location to the next. Um, do some remote firefighting using a UAV with all the wildfires happening lately. It's can we send some UAV out there to, douse some fire in a particular location, right? So that have been some of the prompts in the past, right? So if you're interested in aerodynamics, aircraft design, there's a lot of stuff that goes into that. So even if you're interested in just controls, I mean, you have to figure out control surfaces and how the wings are gonna, the ailerons and ailerons are gonna move to control this thing and all that sort of stuff. So if you're really into aerodynamics, this one could be for you. All right. Patterson projects. Man, Patterson just comes up with the greatest ideas every year, man. So one of the projects that Patterson's proposed is the design and build of a 3D printed RC motorcycle. So if you like motorcycles and you like 3D printing, man, this is a gold mine for you. But the goal is to create a 3D printed motorcycle that can go up to 50 miles an hour. Man, that's booking it. For 20 minutes, right? A good amount of battery time. So made with the ME department printers. This is a bit of a challenge, man. Designing something with two wheels is much more difficult. In the past, he's done like go-karts, mini go-karts with four wheels. Four wheels easy. A motorcycle on two wheels, it's pretty hard. So good luck. You're also going to use Rosie to run fluid simulations. Many of you have seen like the virtual wind tunnel that Patterson sort of put together for Rosie, so that's kind of a cool thing. You need to have taken fluids and completed it by the end of this term, and you have to take CFD in the fall if you want to do this project. But 3D printing, aerodynamics, motorcycles, CFD, all cool stuff that goes into this project. Another thing Patterson is interested in doing is making like an automated system of robots that work together to achieve a goal. And the first project towards that he's proposed is creating a scale model of a fleet of like automated guided vehicles that are working together to achieve a task. And in this case, the task that he wants to achieve is sort of like emulating robots that work in Amazon's warehouse. So they're transporting items all over the warehouse floor. Maybe some of you have seen them. They look a bit like this. And so your goal would be to create 6 models like that look a bit like the robots that you see there that can maneuver items around a floor and work together without like hitting each other, right? So controls, instrumentation, someone's going to have to be in charge of the design of these. How does the drivetrain work? The wheels, how do they steer? What's their vision like? Those sorts of things. So robotics, vehicles, but this one's going to be super cool for sure. One other one that he's proposed is not just automated guiding fleets of little tiny robots on the ground, but also automated cranes that can pick up objects that the guided fleet have moved around and place them in another location. So cranes that have vision that can pick up items reliably, that can move reliably, place objects down reliably, that won't break under normal operation. So you got to be kind of good at statics for this one as well. But it's a similar idea is that Patterson wants to make this little mini like port where you got all these little robots moving stuff around and then you got cranes like taking stuff everywhere and they all kind of work together and I think it's kind of like this little mini city that he wants to like build and talk about and maybe later integrate some AI or something. I don't know. He's got all these great ideas, but I think this one would be kind of cool. All right. SAMPE. SAMPE is a Society for Advancement of Materials and Process Engineering, and they have a competition each year to design and build a bridge out of fiber reinforced composites. So this is one I'm going to advise. I've never competed in this design competition before, but I've seen it live several times when I've gone to the SAMPE conferences. So the goal is to design and build a bridge out of composites. And you can see a carbon fiber like bridge here that some of these engineers are putting into what looks like 4-point bend. And each year they have a prompt that differs. Like it must be this size, it must hold this weight, it must be this shit, it has to be restricted and it can't do this or whatever. And so we'll make some bridge out of fiber reinforced polymer composites. We'll win the competition. It'll be awesome. So come do this project with me. You'd have to take the composites class again if you wanted to compete in this one. All right. This one is, I think, awesome. So I've been talking to some professors at MIAD, which is an art school in downtown Milwaukee, specifically this guy, Frank Savage, who used to work at Harley-Davidson for 25 years, and now he's a professor at MIAD. So MIAD's the Milwaukee Institute for Art and Design. It's highly ranked as one of the best art schools in the country. And MIAD students have a senior design as well. Like it's very similar to what we do here, where they do something related to their major. And one of the majors they have over at MIAD is product design. And product design has a lot of overlap with mechanical engineering, where they're developing and building something that has to look nice, it has to have function, it has some form, and be ergonomic and all that sort of stuff. But they don't necessarily have like the analysis and mechanical drawings and manufacturing knowledge that you guys have. So the idea here is that you would pair up with a student from MIAD, or I think we're going to do maybe two and two MEs, two MIAD product design engineers, to develop and build some prototype for a competition to be entered into March. So the students participate in this International Housewares Association Future of Home Innovation Design competition each year, and that competition involves developing some houseware, whatever that is. There's a wide range of housewares that you could imagine, and you're going to develop everything about it. The artistic renderings, you're going to make a prototype, you're going to make mechanical drawings, you're going to do the analysis, statics, dynamics, mechanics of materials, whatever is associated with that thing. So the MIAD students would be responsible for the design, ergonomics, artistic renderings, user experience, proof of concept, prototyping, and you would be responsible for the mechanical engineering side of it, right? So manufacturing methods, technical drawing, mechanisms, full-scale prototype, etc. Then you guys will enter the competition together and work together. So I think this is going to take a bit of somebody with some spirit about like design and art that goes into design product development. So if product development has ever been something that you want to think about or an itch you wanted to scratch, this could be one for you. So these MIAD students are serious, man. Like they know how to use SolidWorks. They can develop prototypes. Like this girl here is showcasing her prototype, which is a water bottle that has UV inside of it to help clean the water. Yeah, they got some skills. So I don't have any artistic skills. So if I wanted to ever make artistic renderings, I would have to work with somebody over there. But this is something I think would be cool to try if you have sort of an art side that you want to scratch, maybe. All right, impact tower. We have an impact tower in S214, like the side room of that particular room that doesn't really work anymore. Instron stopped servicing these particular models, and this model that we have, it actually like behaves really well. Like mechanically, all the mechanical components work, but the software doesn't work on it anymore, more or less. So what we're asking for is a team that could maybe design a control system and refurbish this frame so that we can use it for experimentation in our like mechanics and materials classes, more or less. So a new control scheme for the drop tower, maybe some refurbishment of components, etc. And you will likely have some computer engineering students as part of the team that can help you out with this. So some of the software side, right? So if you have interest in software controls, impact dynamics, refurbishment, reverse engineering, I think might be important here. This one might be for you. Moving back into the medical space, Dr. Rizza and Dr. Tatari have proposed a project to understand how well an ankle-foot orthotic might fit on a patient without actually having the patient come in and try it on. So in order to save patients some time and the heartache of getting to a hospital, especially if they have like a broken leg, let's say, it would be nice if you could understand how an ankle-foot orthotic is going to fit on a patient without like the expertise of an orthotist, right? Somebody who like studies and knows foot orthotics very well, and without having to get patient feedback. So they want to create a computer-controlled simulation that can sort of understand how effective an ankle-foot orthotic design will be without requiring it to fit on the patient. All right. This might be for people with interest in medical devices, ergonomic factors, and maybe computer software. All right, just a few more to do here, and then we'll wrap up. Last ones here are proposed by students or alumni. So the first is proposed by Ahmed with Dr. Schaefer as the advisor, and it's to sort of adapt some things on the Formula hybrid vehicle that we have in competition each year. So this is the Formula hybrid vehicle. I think I stole this picture from their website. Maybe this is from last year or 2 years ago. And there's been a proposal to redesign the upright assembly of the Formula hybrid vehicle. That's a lot of portion of the vehicle, but specific emphasis on the wheel hub assembly, the knuckle and the seats and the bearings. But there's also possibilities of like looking at the braking system as well. So some of the braking system, some of the upright assembly, which is more or less this frontal portion of the vehicle, looking at the redesign of that. So if you're interested in vehicles, steering columns, assemblies, braking systems, maybe this one is for you. NASA Lunabotics. This one's kind of close to my heart. I did a project somewhat similar to this when I was a senior. Is looking at a test chamber for testing components in a regolith environment. So regolith is the dust on the surface of the moon. So it's just a fancy name for like the dirt of the moon, more or less. And this regolith that's on the surface of the moon is very electrostatically charged. It has a lot of very strange properties associated with it. And so the Lunabotics team wants to make a test chamber filled with regoliths that they can use to understand how mechanisms might work in that sort of environment. So this is a test chamber that you're going to be making. And so if you're interested in space components and space environments, mechanical testing, dust mitigation, I think is going to be big here when you're talking about regolith. This one could be kind of fun. Lastly, there's been a project proposed about using a multi-phase fuel injector for injecting fuel into a turbojet engine. So the idea of can we use liquid fuels or gaseous fuels to power an IC engine, in this case, not an IC engine, a turbojet engine. And so this is something Dr. Venkat wants mostly as a demonstration unit for maybe some of his courses, maybe the jet engines course that he teaches. But if you're interested in engines, fuel injection, multi-phase systems, because you have to think about liquid fuel, gaseous fuel, how you're going to handle them, how you're going to maybe change between liquid and gas, and how you're going to get those as part of the fuel source for the engine. This one might be for you. That's it. That's all the proposals. So there's a box folder that has a lot more detail about some of these, including like the full proposals that outline a lot more information than I'm able to cover here, right? I only get like 1 minute per project. I just presented almost 40 projects. So that's that. I'm going to send an email to all of you in just a moment with a link to this box folder and the preference form. So please fill that out. You have until next Friday to do that. That's the 18th. And then the survey will close the following day. So do that. Good luck. Godspeed. I'll do the matching. You'll hear from me. All right. I'll hang out if there are any final questions here. Otherwise, that's it for this talk. Thanks.
Thank you. Goodbye.
Thank you, Dr. Hart.
You're welcome. Fill out your forms.